Hi, in this video I'm going to explain how to analyze a PID. A PID is a piping and instrumentation diagram. It is a representation of a process flow between all process units or equipment in any plant. It is a complex drawing compared to PFD. Do you remember PFDs? There are drawings that illustrate the general plant streams. They basically provide detailed mass-energy balance data along with stream composition and physical properties, so PIDs originate from PFDs. It includes all piping connected between equipment and the associated instrumentation necessary to design, construct, and operate the plant facility. For this, it uses various symbols to represent the equipment. It is important to mention that it is used during the entire life cycle of the plant. Being established that it includes every mechanical aspect of the plant, now I'm going to tell you what it doesn't have. First, we have the operation conditions, temperature and pressure. Then the stream flows, the equipment location, the pipe routing, this being pipe lengths and pipe fittings, and finally the support structures and foundations. So the key for understanding PIDs is identifying the components. So every time you see an instrumentation or control symbology, you can answer the question, what is that device? Where is it located? And why is it there? In this table for instrumentation and control symbols, we can see different figures, but in the columns they represent the position and the lines represent what it is. So for example, for this first figure, it means that it is in a sub-panel or remote location and it is graphics on a computer screen. Then for this second example, it means that it is locally mounted, so it is in the field and it is specific for computer functions. And then this third example means that it is inaccessible, hidden or back inside the panel, and it represents instruments and devices. Now we are going to see some examples for valve symbols. The first one is a ball valve. Then this one is a butterfly. Then this would represent a diaphragm. Then we have a gate valve and finally a globe valve. Other really important kind of symbols are line symbols because they can represent really different kinds of connection. For example, this regular line is just for a regular piping, so it's a major process piping. Then this kind of line represents an electrical signal. Then we have this kind of line with like crosses that it represents the capillary tubing. Then this kind of line with circles is for software or data link. And these other lines are for pneumatic signals. This table here represents the instrument letter identification, and it is going to help us identify the symbols. So, for example, if we have a circle like this, we already know that it represents an instrument or a device and that it is locally mounted. Then, the first two letters are going to represent the instrument function, and for this it will be a level at a primary element. Then this number here could indicate quantity or other supplementary data. Then we have numbers on the bottom. This means the device tag or the loop number for the instrument. And finally we have another letter here that it's a modifier suffix, and that works for when we have two of the same instruments and we have to identify each of them, so we put A, B, etc. To clarify this information, we have here a lot of examples. These are common primary device symbols, and we can see that we have analyzer, level, temperature, pressure. Nevertheless, as you can see in the first line, they only have an I, so that means that they only indicate. Then the second one means that it only transmits, and the third one would indicate and transmit, and the last one would also indicate and transmit, but it also has a letter D. That's a first letter modifier that stands for differential. Finally, we get to the interesting part. This is a really simple example of a PID, but here we can see that we have a valve. The thing that it's above the valve, it's a pressure reducing, it's an external sensor. Then it is connected by a pneumatic signal to the temperature valve, and this receives an electrical signal from a temperature indicator controller. This indicator controller receives another electrical signal from a temperature transmitter that is connected directly by a capillary tubing to the heat exchanger. So it receives the temperature from the heat exchanger. It then changes the signal, and it goes all the way to control the steam in. Then this heat exchanger has an outlet that is just the heated product, and it has another inlet of product, but this one just has a regular valve. So this is the end of the tutorial. I hope you enjoyed and learned a little bit more about PIDs.